In this video, we're going to look at properties of similar shapes, and when we scale shapes, we enlarge them. Now, we saw in the previous video that if we enlarge one triangle to make a bigger triangle, so we kind of make it bigger, we enlarge it, the lengths are scaled by the same factor. So by that, I mean, well, if this bottom length of the triangle is doubled to become this length of the bigger triangle, then it also means if we take this length of the top, the hypotenuse, that must also be doubled in length. But the other thing that we saw, which is relevant to answering this question, is that the shape and the angles remain the same. So this triangle, it's still the same triangle, but just bigger, and the angles remain the same. So that 90-degree angle remained as 90 degrees, and that 44 degrees remains as 44 degrees, so x was 44. So the same principle is here. This triangle is enlarged to become this one. It remains the same shape, it just becomes bigger. So this 58 degrees here must be the same as this angle here, because the angles remain the same. Now, this is an isosceles triangle, and we can see that this length here is the same length as here, because we can see that we've got a little mark on these two lengths to indicate they're the same length. Now, if these lengths are the same, then this angle will be the same as this angle here. So this angle here will also be x, right? Now, these three angles add up to 180 degrees. So if we subtract the 58 from 180, that gives you 122 degrees. And then if these two angles add up to 122, we can share them equally between the two angles. So we just divide by 2. And that gives you 61 degrees. So that means x must be 61 degrees. And we are done.